Hello guys, this is Code and Code, and this problem is finding the kth prime number taken from SPOJ. So we are solving this problem in continuation to the previous lecture and in that lecture we have studied about sieve. So we are going to implement sieve to solve this problem. We have to find the kth number. So the question is very simple. You are given q queries. In each query you are given k and you have to print the kth number. K can be as large as 5 million. So of course we have to run sieve, or basically we should have a list in which we have all the first 5 million prime numbers. To do that, first 5 million first 5 million prime numbers can be found in the limit up to 87 million, as you can see in the comments, but we are going to generate prime numbers till 90 million. So till 90 million, in the list of integer from 1 to 90 million, we can find first 50 million or more than that prime numbers. So we would have a list of integer, that is vector of int primes. This list would store all the prime number. As 0th index we would have first prime number, and as first index we would have second prime number, and so on. And then in this case I will be using bool array, and then 90 million. Yep, it is 90 million. So an array of size 90 million, and I'm using bool this time, not integer. The reason is the time limit of this problem is very tight. As you can see, the time limit is 1.24 seconds, not even 2 seconds. So, and since we are going to generate all the prime numbers till 9 into 10 to the power 7, so if you are going to use integer, then you are going to get TLE, of course. So we would use bool because bool uses 1 byte in C++, and int uses 4 bytes, so it would save space and time as well. So now let's generate all the prime numbers till 90 million. So for that, let's just define max n to be 90 million. Okay, so I guess yep. And now since we know AR of 0 is equals to AR of 1, that is equals to 1 or true. In this case, what we are going to use, if the ith index is false, which means it is a prime. If the ith index is true, then it is not a prime. So 0 and 1 as 0th index and index 1, I have saved true because 0 and 1 are not prime number. So we would start from 2 and go till square root of max n, and if ith number is prime number, then we would have false there. And why I am using false, because if you, in C++, if you declare an array globally, then if it is integer array, then all the values would be initialized by 0. If the array is boolean, then all the values would get initialized by false. So all these elements contain false in there. All the elements are initialized by false, and so we would use false as the indication of prime number. So since 1 and 0 are not prime numbers, so we have initialized them as true, and the rest are still false. So if the ith number is false, then its negation would be true. So we would check if the ith number is false, or you can simply say to this, if ith number is false, then it is a prime number. So instead of doing this, you can simply apply negation, so it would become true. So this if condition would be executed. So if the ith element is false, then what we would do, we would mark all the multiples of this as composite. Composite means true. So you see, true means composite and false means prime number. So starting from 2 till square root of max n, we would check whether the ith number is prime number or not, as I have already explained in the sieve video. So if the ith number is prime, then AR of I would be false, so we are using if not of AR of I, which means if the ith number is prime number, then we are going inside, and starting from I square we are marking all the multiples of I as true, that is as composites. So now at last 2 to max n, if AR of I is equals to false, which would indicate presence of a prime number. So if AR of I, we can simply use not again. So if the ith number is prime number, then in our list prime we can simply insert this number. So if ith number is prime, then we are inserting the ith number in the list of prime number. So at the end we would have all the prime number inside this primes vector of int. So primes vector. Now so we have q and n. Seen q, after reading q, just call sieve to initialize all the elements in prime vector. And now while q minus minus, simply read n and print primes of n minus 1, because first prime number would be at nth prime number would be at index n minus 1. So this is all. I don't think we would get any error, or maybe we can. So if you see, this is the test case. Let's run the test case. So we are having some, oh okay, it takes time. Yep. Sorry, I think we messed up something here. So 90 million, yep, 9 into 10 was 7. Okay, 9 into 10 was 7. That's good. Okay. J is less than equals to, oh sorry, here we have to mark all the multiples of j, not I. So here I by mistake wrote I instead of j. So there are no other errors. Sorry, there are no other errors, so it should work fine now. It is taking time to pre-compute, and then these are the answers. As you can see, for the last one the answer is 15, 45, 58, 63, and here you can see 1299, 709, 1299, 709, and so on. So let's just submit this and hope everything goes fine. Submit. Most likely we are going to get a time limit exceeded. Oh, we got accepted. And we have used 121 MB of memory. Try to reduce memory and time limit by yourself, because as you can see in the comments, you can see people have solved it in 0.4 seconds as well, and our taken time is 1.13 seconds. So we are far above the time limit of others. So one way to reduce it, to calculate all prime numbers till 87 million, we have used 90 million. So what we did is we first generated all prime numbers till 90 million, then we saved prime numbers into the vector primes, and then simply we read input n and then simply print out the nth prime number. So this was very easy problem. So I think you've got the idea how to solve the problems using sieve. And if you have any query, just comment it out in the comment section. And till then, thank you guys for watching, and yep, keep coding. Thank you.